I'll move that up a little bit. All right. So this is section 1.7. It says find perimeter, circumference, and area. These are topics from elementary and middle school, so they should be pretty familiar. A lot of this chapter 1 stuff should be reviewed. The first thing we need to talk about are formulas. So we're going to talk about formulas for perimeter and area and circumference. First off, perimeter. Who has a good explanation of perimeter? Yes? The distance around the outside of a polygon. I like it. If you want to write it down, go for it. I would go ahead and do it. So perimeter, it's the distance around the outside of a polygon. That's a nice simple definition. I like it. It's really similar to another word up there, circumference. The only thing is circumference is like the perimeter of what shape? Okay, circumference is like the perimeter of a circle. So circumference So make sure to note that. These are the two key words. They're really linked together really closely. The last word up there is area. And area is different than perimeter and circumference. Perimeter and circumference go around the outside, around the edges of the shape. Area is kind of different because it does what? Okay, it's not exactly the total distance taken up by the shape. It's the amount of square units that fit inside a shape. For instance, on this square, if I just said these were units, we would say how many of these little squares fit inside that shape? So we would draw a grid and we'd keep going, and we would say how many of those units fit inside? That is area. So how many square units fit inside a shape? Fit inside a shape. And I didn't just limit it to polygons because circle also has area, so it's a rounded shape. It's not a polygon, but it still has area. The next thing we got to say is, what are the formulas for each of these shapes? So does anybody know the perimeter formula for a square, dealing with S as the side length? Okay, we can do S plus S plus S plus S 4 times. What's the faster way? S times 4 or 4S, yeah. That's the fast way for perimeter on a square. Area of a square. A lot of people say length times width, but we don't have L and W, we have S, and the S's are the same. And when you do S times S, you get S squared is the fast way. So that'll really test your geometrical thinking. If you say length times width still, it means you're probably still thinking back to elementary school terms. We're going a little bit higher than that. Rectangle, now you can go back to that old school stuff. So let's do area first. I think that's the simple one. What's that? Length times width. Perimeter, does anybody remember that? Usually we add all the way around, so there's length, width, length, width. How many lengths are there? There are 2 lengths, and then you add them to 2 widths. That would be the faster way. Triangle. A lot of people miss this one. A lot of people miss this one. In this case over here, perimeter, it's not a real quick, fast formula. You just go the old school way. You add up the sides. You add A plus B plus C. A lot of people miss the area formula for a triangle, though. A lot of people. Does anybody know it? Half base times height. 1/2 times the base times the height. And that's kind of cool because it's really similar to a rectangle. Check this picture out. If I draw a rectangle and I say base and height, its area is going to be base and height. But I can easily make that into a triangle. And just look at that. When I just do that, I've taken 1/2 of the base and height to make a triangle. That's where it comes from. That's why it's 1/2 base times height. So that's an easy way to remember. It's closely related to a rectangle, but it's half of it. You draw a triangle by connecting the opposite vertices. Circle, a lot of people miss these formulas as well. Does anybody remember either of those formulas? All right. Area is one you better know. Pi r squared. Pi r squared. Circumference, pi d, pi times diameter. But sometimes they'll want you to write it in terms of r. A diameter, how's a diameter related to a radius? Oh, 2 times. Okay, so if I put 2, sorry, I could go half. Let's do 2r times pi. Another way could have been, I'll write out to the side. It's not as common. That's good. That'll be good. And then we'll move on from there. In example 1, it says, in the inbounds portion of a singles tennis court as shown, find its perimeter and area. So we can do that fairly easily if we use the 2 formulas. I think area is the easiest one. So let's try that first. What number do we want to consider as our length? The long one? Okay, I'll go with that. So 78. And the width, 27. If you multiply those, you can quickly get your answer. So we get 2,106. And we need units since it gave us units. So it's feet squared, or square feet. How many square units? 2,106 square feet fit inside there. Perimeter is very similar. Which one did we say was our length earlier? Okay, the long one works. And then the width. And then we plug in those values into the calculator. When we do that, we get 210. Now be careful. What are the units when we're doing perimeter? Just plain old feet, because it's a linear distance around the outside. So you'd never run 210 feet squared. That wouldn't make sense. When you're running around the outside, you're just running linear feet distance. Now try the checkpoint. See what you can do. In the checkpoint, it says the width of the inbounds rectangle increases to 36 feet for doubles play. That means you're actually adding on little pieces to the right and little pieces to the left. We actually call these alleys in tennis. So a little alley to the left and a little alley to the right on that shape. And now it's gone from 27 to 36. Now we got to plug in those same formulas. And you can use those same exact blanks if you want. You can erase or just write it out to the side. So I would do 2 times 78. Add it to 2 times 36 now. When you type that in, what do you get? 152? What? 228 feet for the perimeter. So be careful when you're typing in. A few people have typed it in wrong. Area is going to be very simple. 78 times 36. 2,808 feet squared. Make sure to have your units. I will be very particular on that. Example 2 is a great question. It says the smallest circle on an Olympic target is 12 centimeters in diameter. Find the approximate circumference and area. So I need to be able to write my formulas and understand them first. So let's try that. So area formula, who remembers that? You can look if you need to. Pi r squared on a circle. You need to memorize this to know this. I can tell a lot of you don't know it. For circumference, what is that one? Pi d, okay? Or you could say 2 pi r. Either one would work. We do not use 3.14 in this class. We use the pi button. That's one thing I want to point out. Note that in the side, in the margin. We use the pi button because it's on our calculator. When you were in elementary school, you probably didn't have a pi button. That's why you didn't use it back then. Since we have that button, it's much more accurate now to give our best answer. So let's try this area one first. It says we need a radius. Were we given a radius? No, we were given the diameter is 12. How do you go from diameter to a radius? Cut it in half. So if the diameter is 12, the radius is going to be 6 centimeters. Now we can plug that into our formula. So we're going to have pi 6 squared. Try typing that in and see what you get. 113.09 is what I heard. Somebody double check. Don't forget your units squared. Is that correct? Are we all in agreement? Great. Perimeter, 2 pi r. In my opinion, that's the harder formula to use since they already gave you diameter. But let's just go with what they're doing. 2 pi r. So 2 times pi, and the radius we just found was 6. You could have just typed in 12 times pi, and what would you get? 37.69, and we'll say centimeters there. Good job. Yeah, go down and try that checkpoint on your own. I'll give you a little bit to try it. On this next checkpoint, they give you a little piece on a picture. They don't tell you what it is, though. Is that a radius or a diameter? A radius always goes from the center to the edge on the circle. So that is a radius. So I can substitute that into both my formulas that we discussed earlier. So A equals pi 8 squared. When you type that in, what do you get? 201.06. And units, don't forget to say units, meters squared. Not bad. Circumference. Since they gave us radius, let's use the one that uses r. So 2 times pi times 8. Or you could type in 16 times pi on your calculator, and what do you get there? .26. And units would be meters. Cool. Any questions? On example 3, it says triangle JKL has vertices 1, 6, 6, 6, 3, 2. Find the approximate perimeter of the triangle. So that means we need to graph it and then do some calculating. So I'll give you time to do that. Once you've graphed it, it should look something like this little figure over here. Now some of those pieces are easy to find their length because all you have to do is count. You can always count whenever a segment is along the grid. So we can easily count this one. 1, 2, 3, 4, 5. JK is 5 units long. And I would just write it out to the side. JK is 5. We need to find the other ones, though. We need to find JL and LK also. That way we can do a total perimeter. To do that, we need to find the length. To find the length, we need to practice the distance formula again, just like we did earlier in the chapter. So if you don't remember, the distance formula can be written like this. You need to write this down. x2 minus x1 squared plus y2 minus y1. And then you'll plug in the appropriate values. So these are the values we need to be examining up here. The first one they say to look at would be JL. So let's focus on J and L right now. We'll call them X, Y, X, Y. This one comes first, so I'm going to say x1, y1. This one comes second, so I'll say x2 and y2. I need to plug those into my formula. When I do that, I should get 3 minus 1, and we can fill in the blanks. The other part is going to be 2 minus what? 6. So once again, they do a lot of shortcuts here. Let's see if you can calculate that, and then we'll go. So don't forget, 3 minus 1 is 2, and 2 squared is 4. Over here, 2 minus 6 is negative 4. Negative 4 squared is 16, and 4 plus 16 is 20. When you type in square root of 20, what approximate answer do you get? 4.4 units. So I know another piece now. Try to do the same thing for LK. I'll let you try it on your own. When you try this one on your own, you should relabel. It says LK, so I put L as the first point and K as the second point when I relabeled. Then I'm able to plug in 6 minus 3, and then 6 minus 2. These are some easy values to get. 6 minus 3 is 3. 3 squared is 9. 6 minus 2 is 4. 4 squared is 16. Add those values, and you get square root of 25. Type in square root of 25, and you get 5. The last step to do is to add all these up, and it's pretty easy to add them. 5 plus 5 is 10, plus 4.4, and you get a total of 14.4 units. Good job. All right, this next question says, you're using a roller to smooth the lawn. You can roll about 125 square yards in 1 minute. I like to write that as a rate. So 125 yards is written like this. 125 yards per is divide 1 minute. That's a good way to start. About how many minutes does it take to roll a lawn that is 120 feet long and 75 feet wide? So I need to find the area of this since I'm measuring in square yards for my rate. So let's first find this area. So 120 times 75, since it's a rectangular lawn, what do you get there? All right, so we get 9,000 yards, square yards. And now I'm going to use this in a proportion. They do it a slightly different way, but it still works that way too. So I'm going to do a proportion. I'm going to say, all right, the yards per minute. So we have yards per an unknown number of minutes. We can cross multiply and solve this pretty easy. 9,000 times 1 is just 9,000. It's good to have the yards as well. 125 times x is just 125x. Divide by 125 on each side. And we get that unknown is 72. So what does that mean when I write 72 here? X is 72. That's our number of minutes. It will take us 72 minutes to mow 9,000 square yards. It's pretty good. Example 5 is a little bit different than what we've been doing, so be ready. The base of the triangle is 24 feet, and it's labeled. Its area is 216 square feet. So they didn't write that out. I'll write it out here to the side. Area is 216 feet squared. Once again, this piece right here is our base, and our height is unknown. I'm going to substitute these values into our triangle formula. But first, we have to remember our triangle formula. What is that? 1/2 base times height. Hopefully you will memorize that this weekend or tonight if you don't already know it. We're going to substitute values. Do we know how big A is? Yeah, we do. We wrote that out to the side. So 216. And we have 1/2. Do we know how big the B is? 24. It told us that as well, and it's labeled in the picture. Do we know how big H is? We do not know the height. That's what we're going to be solving for. So it's a little bit of Algebra 1. First thing I would do is take half of 24. What's half of 24? 12. That's pretty simple. last step, we divide by 12 on each side. And what do we get? 8. So the height is 18 feet. Good. These are our last checkpoints. See if you can do these. I'll give you a little bit of time. On checkpoint number 3, it says find the perimeter of the triangle shown at the right. Remember, you can always count whenever you're along the grid, so that's 3 units. So I can say BC is 3. The other pieces, though, it'd be smart to label and then plug into your distance formula. So that's what I've done on the first one. And I got square root of 61. When that's rounded, what's it approximate to? What's the approximate answer? 7.81. And then on AC, whenever you approximate that one, you get 6.32. To get a total, you need to add them all up. So it'd be smart to write that down somewhere. So 3 plus 7.81. Then add 6.32. And you get a total of 17.13 units for the perimeter. Good. Good job. On number 4, it says, suppose the lawn is half as long and half as wide as the one in example 4. So take half of those values in example 4. And then it says, will it take half the time? Well, we need to examine that proportion again. So the proportion, in that upper left, we did 60 times 37.5. What does that come out to be? That's our area. What do we get when we type that in? 2,250 is what I heard. So I can substitute that in. Once again, that's per 1 minute. The other part, what was in the other part? Does anybody remember? Oh, it was the actual rate. So that was 125 per 1 minute. So this is the piece we're trying to find. We mowed this amount in an unknown amount of time. Cross multiply from there. So we get 125 times x equals 2,250. Divide by 125, and what do we get? 8 or 18? 18. And what are the units on that answer? Well, remember, this is the yards per minute, so that's a minute. So it'll take 18 minutes. Is that half as long as the previous time? Is that half as long as the previous time? Okay. We can compare that value back to our answer on example 4, and it says right there that it took 72 minutes. So is that half the amount of time? No. So this is actually a no answer, because 18 is not half of that 72 minutes. On the last problem, it's very simple to example 5. In this one, they give your area, which is in square units, so 96 is our A. They give you a height is 8, so there's your H. We got to find the value of the base, which is our B. So when we substitute that in our formula, we can do a little simple math. We can quickly do half of 8, which is 4. Then we can do 96 divided by 4. And that will give us a base of 24. And don't forget to put units, and our units are in inches. Good job.